This video will provide an overview of yarn manufacturing within the textile industry. Textile refers to any material made of interlacing fibers. These raw materials are converted into yarns, which are then used to create fabrics, as shown in this simple flow. Fibers can be classified into several types: cellulosic, protein, synthetic, and mineral and organic fibers. Examples include cotton, silk, nylon, and carbon fiber. Key properties of fibers necessary for spinning into yarn include sufficient length, tenacity or strength, elasticity or elongation, and uniformity in size and flexibility. Yarn is defined as a continuous strand of textile fibers or filaments suitable for intertwining to form fabric. Yarn characteristics directly impact the performance and end use of the resulting fabrics. Yarn is generally categorized by fiber type, being either staple or filament, by structure as single, plied, or cord, and by appearance as simple or complex. Yarns are twisted to hold the fibers together. The direction of this twist is described as S direction or Z direction, based on the slant direction of the spirals. Yarn size or number is measured using either the direct or indirect system. The direct system uses denier, tex, and decitex based on the weight of a fixed length of yarn. In the direct system, a higher number indicates a coarser yarn. In the indirect system, where count is based on the length of yarn and a fixed weight, a higher number indicates a finer yarn. The general yarn manufacturing process involves several steps: blowroom, carding, drawing, roving, and ring frame. Combing is an optional step that takes place after drawing. The blowroom is the first step in cotton yarn production. Its purpose is the opening, cleaning, dust removal, and blending of fibers, preparing them for the carding process. Carding is a critical process with functions including opening individual fibers, eliminating impurities and short fibers, blending, orienting fibers, and forming sliver. The main parts of the carding machine are the taker-in for opening flocks, the main cylinder for separating and paralleling fibers, and the doffer for removing individual fibers into a web form. The drawing process aims to improve the evenness of the sliver, arrange fibers in parallel, achieve blending, and remove dust using a draw frame with rollers rotating at different speeds. Combing is an optional step to upgrade raw material by removing short fibers, resulting in a stronger, more uniform, and smoother yarn. Its main functions are to eliminate short fibers, remaining impurities, and neps. Roving is the stage where the sliver is attenuated, protective twist is imparted for increased strength, and the roving is wound into a package for ring spinning. Spinning is the final step in producing yarn, carried out on the ring frame. Its functions include attenuating the roving to the required fineness and imparting strength through twisting, finally winding the yarn for further processing. Within the spinning process, the drafting system is divided into the back zone draft, middle zone draft, and front zone draft, each contributing to the final yarn properties.